Okay, class, this is section 11.2. And we are just going to look at similar triangles in this section. Section 11.1, we looked at all kinds of polygons, hexagons, and pentagons. But in this section, we're going to focus just on triangles. Okay, so for two triangles to be similar, they still need to follow the rules of any similar polygons. All their corresponding angles have to be congruent, and the corresponding sides have to be in the same proportion. So that is going to hold true for our triangles. If you remember in the first semester, we studied congruent triangles, and we had to prove them congruent, and we used different methods of doing that. We use side-side-side congruent conjecture, side-angle-side, angle-side-angle. So in this section, we're going to learn how we can prove triangles similar, not congruent, but similar. So this first investigation, we are going to find out, is AA a similarity shortcut? So AA stands for angle, angle, and you're going to do a little investigation and decide if it works or not. If you would like to do this investigation in Sketchpad, that is fine with me. You can do that. Just make sure you save your sketch at the end so that I can look at it. Now, in this investigation in the book, they want you to make congruent angles by constructing them using a compass. If you would rather copy angles using patty paper or a protractor, that is fine with me. You can do that. So I want you to draw any size triangle ABC on a piece of paper. Label it triangle ABC. But then you're going to construct a second triangle, DEF, with angle D congruent to angle A and angle E congruent to angle B. So in copying those angles and making sure that they're congruent, use a compass, use a protractor, or use a piece of patty paper to make the copy. So what can you conclude about angles C and F? I think we know for sure that angle C will be congruent to angle F, but you want to make sure that that is true. After you've done that, step 3 says to measure the lengths of the sides in both the triangles and then compare the ratios. Compare your results with others. That's what we're going to do in class tomorrow. But then I want you to kind of make an educated guess on what you think the angle-angle similarity conjecture is going to say. You can go ahead and type this into your notebook. Tomorrow in class, we will make sure that you have the conjecture right. Keep in mind, you started with two congruent angles. Can you conclude that the two triangles are similar just from two congruent angles? Are all the corresponding sides in the same proportion? You could try another triangle. You can make the lengths any side you want, but just make sure you start with angle D being congruent to angle A and angle E being congruent to angle B. The second conjecture today is a side-side-side similarity shortcut. So we're going to do the same thing with this similarity shortcut to see if the two triangles are similar. We're going to draw any triangle ABC, then construct a second triangle DEF whose side lengths are a multiple of the original triangle. Your second triangle can be larger or smaller. So with this investigation, you might want to use graph paper And do it like we did in section 11.1 when we dilated the polygon. But in this case, you just want to dilate your triangle. So start with any coordinate points for your triangle ABC. Pick a scale factor. It can be a half, it can be 2, it can be 3, and make a second triangle that has 3 sides, just a multiple scale factor size difference than the original one. And then compare the corresponding angles of the 2 triangles. By comparing, I would use patty paper to compare, trace the first one, and then see if the corresponding angles are congruent. Or you can use a compass, or you can use a protractor. Let me know what you discover there. You want to put your discovery in a conjecture. Again, go ahead and get conjecture 92 in your notes. We will make sure in class tomorrow that you have it filled in properly. And keep in mind that you started with 3 sides that were in the same proportion as another set of 3 sides. Okay? Can you conclude that the 2 triangles are similar? I will check your work on that tomorrow. And then the last conjecture that I want you to investigate is the side angle side similarity shortcut. So this is going to be a combination of the last 2 conjectures we've looked at. Is side angle side a shortcut for similarity? Try to construct 2 different triangles that are not similar, but have 2 pairs of sides proportional and a pair of included angles equal in measure. So start with triangle ABC. And then we're going to make triangle DEF. But what I would do is make side AB similar to side DE, but then use the same scale factor between BC and EF. So we want to construct these so that they have the same scale factor. One that you pick. I don't care, half or 2 seems to be the most popular to do. Now, the trick with this, if we have triangle ABC with side AB and BC, B is the angle in between. Remember, this A being between the 2 sides means that we want to make angle B congruent to angle E in our construction. That will be the hardest part. It actually might be easier to start with 2 congruent angles, angle B and angle E, and then make sure that the sides are in the same scale factor. So after you've done that, then I want you to compare the measures of the corresponding sides and corresponding angles and see if the 2 triangles are similar. Are all 3 sides in the same scale factor and all 3 angles, just from starting with 2 congruent sides and an included congruent angle? That's the question. So when you've done that, then you can put conjecture 93 into your notes, fill in what you think is true, and again, we'll check it in class tomorrow to see if your conjecture is right.